are focusing actually on section 4.5, which is resolving life ownership. We talked a little bit about why they occur, and we're going to be talking about 3 strategies for getting rid of them. First one we've already talked about was to use references. So this just explains that we can have a mutable reference as well as a read-only reference. Now, one of the other things that we can do is, it's more of a software engineering problem using fewer long-lived variables, duplicate the value. So there are 2 traits that I want to talk about. We've actually touched on them both. One of them is copy and the other is clone. In order to be copy, a type must be clone. So clone comes first. So up here, we've implemented both. But allow me to show you what happens if you've only got access to clone. This could occur when you have complex types. Instead of the copying of the behavior happening by itself, you need to explicitly call clone. Oh, we've still got the wrong type in there. Okay, so it's actually still not happy with us. It's saying that the second access is not valid, which makes sense because by the time we reach line 17, it's already been deleted. We've already called drop implicitly. So we need to clone it first. And then the clone will be sent to the first call of check status, and the original value will live on. So what's being printed here isn't the original value. It's being copied twice, once in 16 and once 17. But the original value to find line 14 is still available for us. So we could do whatever we wanted. One of the things we might want to do is change 42 to another value. So how do we do that in Rust? First thing we need to do is change the variable to be a mutable value. Mutable, again, if you're new to if you're new to English, just means changeable. A mutable value can have its internals changed. Okay, so that's easy. But what if you can't just implement, just derive? Oh no, actually that's describing derive. Oh, here we go. So if you need to do it manually, here are some tricks. I'm going to use another feature of the livebook, which is being able to copy and paste automatically. I'm just going to copy all of that in there. And let's describe what's happening. First of all, this syntax kind of looks somewhat what's a negative word? It just kind of looks absurd. There's nothing happening in here. We're saying implementing, which is what this is shorthand for, these quote impl blocks is the way that Rust programmers tend to refer to them. But there's nothing implemented in here. And that is because they're just what we call a marker trait. So copy is an indication to the compiler. It's not a public interface in the same sense that you might be used to it. There are several marker traits, and they provide a guard for sort of a syntax at a compiler level. I don't know if that makes any sense. Hopefully it does. I can explain that. Okay, so to implement clone, and in fact, to implement any trait, all I need to do is implement its methods. So clone has a single method, and we can find the definition of clone on the Rust doc site. So we're looking for clone, aren't we? So if I find a trait and I want to know how to implement it, first thing to do is go to the doc site inside Rustlang. Now it says the required methods. The term methods is a little bit confusing here because Rust doesn't describe itself as an object-oriented programming language. The reason why we use the the name method is that they look like methods when we use them. So we've got tiny.clone. This is the only thing we need to do to opt into clone. We just need to return we take a reference to ourself, and we need to return a type of ourselves. Now, the syntax for creating a new type is with a literal. Now, I've just realized that I actually have blown away my own definition of CubeSat. I'll just recreate it. Maybe that will run. That. I've got a bunch of stuff I haven't brought across. So I'll just go back to here, back into the Lifebook, and paste it all back in. Now I can, the whole point of this is to be able to remove the clone and copy derives and do it ourselves. Oh, we've got multiple definitions now. You can see that the compiler is being pretty helpful. We can click around and go directly to the problem. We duplicated our definition. Oh, and now I've changed the name of it in my own code versus where the book was. So I'm just going to change that. And again, down in the literal form to recreate a copy. Oh gosh. We've been able to discuss a couple of ways to get through lifetime issues. Oh, this is a bit silly. We'll just blow that away for now. Status message thing turns up later in the chapter. Sadly, we weren't able to implement functional satellites. I'd love to see a whole bunch of little Rust in action lights. No, that's not going to work either. So feel free to ask any other questions. I really encourage you to engage either with the Lifebook, so you're able to select any text that you'd like and either highlight, bookmark, or add a discussion. One thing that I would like to touch upon is that there is another strategy, and we can wrap our types in other types that behave nicely with this ownership system. RC stands for reference counter, and we're able to opt into reference counting at runtime if that's useful for your program. This imposes runtime cost, but it gets us a little bit of flexibility. Reference counting is also the system that is implemented in most dynamic languages, and so if you've already used JavaScript or Python or Ruby or Perl or any other language, almost, you would have already encountered reference counting. Otherwise, though, I will leave it there. And I really encourage you to play around with the book, play around with Rust. It's a really significant software engineering achievement. I think you'll learn a lot irrespective of whichever programming heritage you come from.